All right. Good evening. All right. So good evening. So in this video, we want to talk about how to solve binomial expansion when we have negative powers. Of course, we have questions that can come out where we have both positive and negative power. Right here, we have binomial expansion with negative power. So let's get right into it. Am I audible? Can you hear me? Can you indicate if you can hear me, please? The general formula while dealing with binomial expansion with negative power is given as this. So we have 1 plus x raised to the power of n equals to 1 plus nx plus n into brackets n minus 1 over 2 factorial x squared plus n into n minus 2, n minus 1 first, n minus 1 first, and then n minus 2 all over 3 factorial. And then in this case, we will have x raised to the power of 3 plus on and on and on. Now I need to state very clearly that the value of x, that this expression will be valid for x being, will be defined for x being between this range. So this is the general formula when dealing with negative power. Now you need to know that in this case, n is less than 1. That means n is a negative number. Now, if n is a negative number, obviously, you know that we can have different possible values for n. For instance, we have 3 plus 6x raised to the power of minus 2. In this case, we see that n is equals to minus 2. We could also have 2 plus 10x raised to the power of minus 3. In this case, we can see that n here is minus 3. We can have several examples. 1 plus 5x raised to the power of minus 4. Now, these are all vivid examples of binomial expansion with negative power. Now, what do you need to always note while dealing with binomial expansion when having negative power? Very, very important. You need to remember that, number one, this is the formula that we are going to be using. You can easily understand the format that this formula moves by. Look through very carefully and notice something. Number one, The very first value inside the bracket is a 1. Number 2, the second value as the variable, in this case x. Now, I need to state carefully that this value of x here, it could be 6x, it could be 10x, it could be 5x, it could be any Okay, can you hear me right now? Is the audio back? Please indicate if the audio is back. All right. Now, what I was saying was you need to look through on the formula and understand how the formula is. The very first value in the bracket, we can see a 1 there. The meaning of this is that for you to use this formula that we're seeing right here, there must always be a 1 as this first value. All right? So everything we see here, it is only this third one that conforms to this format. All right? So you can see this one has a 1 as the first value and then 5x as the second value. So this is the only example that we can use directly. These other two, we have to conform it to look like this. We'll get into that very soon. Now, but also look at what the second value in the bracket has. It has the variable. It has the x variable. Now you need to understand that even though we are dealing with the x variable here, it is very possible for us to have all other variables like y, like z, like p. So this is not restricted to only x. All right. If it was y, that means everywhere you saw y, you'll be having, oh, sorry, everywhere you saw x, you'll be having y. If it was p, that will go the same. Now, but look at something. I also need to spot this out. You need to understand that this x could also be multiples of x. For instance, we can have 2x. We can have 3x. We can have minus 5x. We can have minus 7x. We can have different multiples of x being represented here. This particular one, we're only representing 1 times x. That was 1x. That's x. Now, we could have 3x. What happens if we had 3x? Let's say we had 5x in this case. What will happen if we have 5x or 3x or whatever x is that if you were going to write for this third one now, of course, this is the only one that conforms to this notation because you can see it has 1 as the first value. Let me repeat again. You must have the first value as 1. I will teach you how to always conform any problem, any question, to having 1 as a first value. That's one of the things we're going to do in this class. But let me first explain how to deal with the x so that you don't ever mix things up. Here we had x and we had n times the x, and then at the end, at this place we have this third term, we had x raised to the power of 2, and then the fourth term we had x raised to the power of 3. This is the first term. The first term was 1. Second term is nx. The third term is this. This is the fourth term. Now, if you are dealing with this case now where we have 5x, of course, this is not 1x like in this case. So all that will have to happen is that you have to have it as this. I would write 1 plus, let me just use the minus 4. You know, our hand here is minus 4. So n here will be minus 4. Now, I cannot write x here. That would be wrong, because in this case, the reason why I wrote x here was because we had x here. Now we have 5x. So I have to go on to write 5x. Do you see that? That is the way you apply this formula. Now, permit me, because we are not solving this right now, permit me to skip all this. Of course, you fix the value of n here, but we're not solving this right now. Let me just put it like this. This x squared, I cannot write x squared. All right? I have to write 5x. So let's assume I have solved this one. Instead of writing x squared, I have to write 5x all square. That is the way you solve for the x aspect in the bracket. You do not use this x rigidly. You have to use whatever you had. So if it was 3x that was here, you will be using 3x instead of x. If it was minus 5x, let's say this was minus 5x, is minus 5x you will use in there. Whatever x value you have here, if it was 1x, like in this case, you use the 1x. If it was 2x, you use 2x. If it was 3x, if it was minus 5x, you use it just that way. So of course, if I go on to, let's assume I just ignore this aspect and want to do for the 5x cube, I'll be having 5x everything raised to power 3 for this fourth term. All right, that is the way you solve this value of x in the expansion. Now, let me go on to, that is the first aspect I want to clarify very quickly. So never forget that whatever your x value is what you'll be fixing as the x value here, not rigidly just using x. Please, can you indicate if you truly understand what I just said? Can you indicate if you are very much with me? Can you indicate that you just understood what I just explained? The message I passed across now is how to deal with this second value in the bracket. Do you really understand how to deal with it right now? So we have 5x here. Instead of writing just x, I have to, instead of writing n times x, I have to write n times 5x, because here was 5x, not just x. All right? Okay, good. Now, that is that about that. We go on now to try to take the next piece of the puzzle. You need to understand that, as I said initially, let me repeat. For you to be able to make use of this formula, you must always conform your expression to look like this. That means 1, 2, 3. Look at these 3 problems we have here. This. Only this last one is conformed already. So we cannot go on to apply this formula to these first 2, because the first value here is not yet 1. This is 3. This is 2. We have to find a way to conform this expression to look like 1 plus something before we can use this formula. All right? Now, I've explained how to deal with the x aspect. But look at something. If we have 1 plus x raised to power n, try to find a way to look at the way this expansion was. We had 1 as the first value. That is constant. 1. That will always be 1 in anything you are doing using this formula. 1 is going to be the first term. The second term, which is n times x, it will always be n times x in every of your expansion once you have conformed to this format. Now, all you need to do is to go and find what is your value for n. Don't forget, your n represented the power. That was the negative power. And your x represented the second term in the bracket. That's for the second term. Now, the third term, look at the way the third term went. The third term was n times n minus 1 over 2 factorial x times x raised to power 2. Look at that and understand how it went. The fourth term, look at the format. N times n minus 1, that was the same thing that happened here on the numerator, but with an addition of times n minus 2, and this time over 3 factorial. And instead of x squared, it is x cubed. So if I wanted to write for a next term, look at the way I'm going to write for the next term so that you don't get confused. If I'm going to write for a next term, this is what I'm going to write. Look at it. Of course, you agree with me that it's going to be n times n minus 1 times n minus 2. Now, I will have to add times n minus 3. And it will be over, not 3 factorial now, to be over 4 factorial. And it will be not x raised to the power 3 now, it will be x raised to the power 4. I'm sure you people should be able to understand that. Now, if I wanted to write for another term, it will be obviously n minus 1, n minus 2, n minus 3, n minus 4 over 5 factorial. You can see that. You understand the format, and it will be x raised to the power of 5. So you just need to understand the way the whole thing is going. The first term is 1, constant. The next term is n times x. The next term is n times n minus 1 over 2 factorial times x squared, and on and on and on. This is the fourth term, this is the fifth term, this is the sixth term. I'm sure you can write the sixth term. The sixth term would have been all this numerator with an addition of n minus 5 over 6 factorial times x raised to the power 6. So understand that format, and then you will not go wrong. All right? Good. Now that you understand that, let's now go to the next piece of the puzzle. Now I need to state this also, that remember I wrote something here. I wrote the value for x that makes this expansion defined. The value on which this or for x that makes this expansion defined, this expression. Look at it right here. You may be tempted to omit this because you feel it's not important. It's very important that at the end of your calculations, when you are done solving, always state what value of x makes your expansion defined, that your expansion is defined on. Now, look at it. For this one, this is the next piece of the puzzle I'm trying to explain right here. For this expansion, look at what we have. This expansion, we had the second term here, that means our variable, just as x, 1x. So look at the way we defined what x was going to be, the values for x that the expansion is defined on. We just said that x was going to be between the band of -1 and 1. Now, look at something. Let me teach you this part of things quickly. If I was done solving this question, because I told you already that it is only this number 3 that conforms to this format. So for me to be able to solve this number 1 and number 2, I have to conform number 1 and number 2 to look like this. That's the next piece of the puzzle I'll be explaining. But for now, I want to explain how you set the values for x on which your expansion or your expression is defined on. You see, in this case, we had x. In this case, this is 5x. If I was done solving this expansion, this number 3, what I would have to do to set the values for x would have been, I would say 5x is between 1 and -1. That's what you're going to do, because now, when we had it as just x, look at it here, we used x here. If you have it as 5x, you will use 5x. If you have it as 4x, you will be putting 4x here. If you have it as 3x, you put 3x here. That's just the way to go about things. Now, but you don't stop here, because don't forget, we're looking for the values for x, not for 5x. So this is the first thing you do. You first of all go and fix in whatever your second term, the second value in the bracket is. You fix it as this. This was the first term, second term in the bracket, it was x. So this is the second term in this particular bracket, 5x. So the last thing you will have to do while you are done doing this is that you have to go and solve for only x. So if I wanted to solve for x here, of course I would have to divide through by 5. Then that will now make it be -1 over 5 less than x less than 1 over 5. This would be how you're going to have your final stating of the values for x on which this expression is defined on. So this is the way you do that. Make sure at the end of your solving, you always remember to add this to it. Very, very vital. Now, let's go to the elephant in the room, which is how do you conform different expansion, different expression to look like this format. That is the most important part of the whole thing. Every part is important, but that is the part that I think always gets students stuck. Now, if you have a case like this last case, this number 3, you don't need to do anything. You just need to apply this straight into this, which you saw me doing initially already. But I want to explain how you're supposed to bring this type of situation where you do not have 1 as a first term. How do you bring this to conform to this format? Very simple. Pay attention quickly. There are different case scenarios. In this first one now, it is quite very easy. And even this second one, these two are quite easy to do. So what do you do when you have a case like this? This is what you do. You just factorize, simply factorize. But look at something, please, because this is where people get this thing wrong. This is this bracket. This bracket said 3 plus 6x. Whoops. I want to bring 3 plus 6x. I want you to have at least 1 plus something. I don't know whatever that will be, but let me just have 1 plus. I need to see 1 plus. So if I want to see 1 plus, that means I have to find a way to make this 3 turn to 1. How do I make 3 turn to 1? Very simply, bring 3 outside. You must bring the first term that was not 1 outside. That's the thing. Because if you do not bring that first thing outside, you will not be able to see 1 here. The only criteria that makes you to see 1 as a first term is for you to bring that first term outside. Because if I bring the first term outside like this, 3, and I open a bracket, obviously the first value will now be 1. That's the methodology. Bring the first term outside. That will be 1 plus. Now, depending on whatever kind of question you're dealing with, if you're dealing with questions like this that are very factorizable, that means you can see factors in both of them. You can obviously see that if I did this, I will obviously have 1 plus 2x. It's a perfect, they are perfect factors, because obviously we have 3 going in both 3 and 6. So it makes it work more smoothly. Questions like this are very easy to solve. But you will see another type of question that you will need to be much more careful. Now, look at it. I've been able to redo my 3 plus 6x. I have made it now 3 into bracket 1 plus 2x. Now, this thing I wrote here, I believe nobody following me argues that this is still the same thing as 3 plus 6x, because 3 times 1, 3, 3 plus 2x, 6x. So I just changed the format. I re-expressed it in such a way that, because don't forget, I want to conform it to this format. Now you can see now that I can see 1 plus 2x, which is looking like what I need to see. I can see 1 now. So this is good. But let me tell you where you have to be very careful. This is the place you have to be very careful. This is a common mistake. It is a common mistake that I believe students will want to make, is to now go on and write it like this, minus 2. That would be very wrong, because when you factorized this out, all these things, this whole thing you have right here, it was this. And this whole thing was what was raised to the power of minus 2. So you doing it like this, you have made a very big error in mathematics, because you have gone on now to fix your power only with this side now, rather than fixing with everything, because everything here was what had the power of minus 2. Now, that is the reason why we have to do it the right way. How do we do it the right way? Of course, You already agree with me that you cannot fix the power like this. So what you have to do is you have to go on now and put all these things, the whole thing now, into another bigger bracket like this. So you can see now we have brought this all in one big bracket. Now, bringing it into this big bracket now, we can now go on now to write raised to the power of -2. All right? You can now go on to write raised to the power of -2 because this now is perfect. This and this are the same thing because what you have inside this bigger bracket is the same thing as 3 plus 6x, which was what was raised to the power of -2. So now putting all 3 into bracket 1 plus 2x close bracket, putting all those things into another bracket and fixing raised to the power of -2, you have done a perfect job. All right? Now, what is the next step to take? Please pay attention. This is also a very vital step in being able to solve binomial expansion that has negative power. The next step now, once you are done with this, is that you now go on to split the power in this sense. These are 2 terms now. 3, this is 3 times 1 plus 2x. Now, I'm sure you understand using under algebra generally or under mathematical operation that if I have 2 times 3, okay, let me write it as times. If I have 2 times 3 raised to the power of 2, I'm sure you agree with me that this is the same thing as 2 raised to the power of 2 times 3 raised to the power of 3. If you want us to go on to confirm it, let's confirm it quickly. Sorry, 3 raised to the power of 2, not 3. We can go on to confirm if this is correct. It's very easy. I said this is mathematical. That if you had 2 times 3, everything raised to the power of 2 is the same thing as writing 2 raised to the power of 2 times 3 raised to the power of 2. Let's see. What is 2 times 3? 2 times 3 is 6. Of course, 6 raised to the power of 2 is what this left-hand side gives us. And 6 raised to the power of 2 is what? 36. So the left-hand side gave us 36 when we solved it. Let's see if it's the same thing as the right-hand side. 2 raised to the power of 2 is what? 4. 3 raised to the power of 2 is what? 9. What is 4 times 9? 36. You can see that this theorem is perfect. So we're going to use this now to respond to what we have here. So that means if I can say 2 times 3, everything raised to the power of 2 is the same thing as me splitting it up. That means splitting 2 with the power of 2 and 3 with the power of 2. And we have established that that is correct. So we can go on now and do the same for this expansion or for this expression. So that means this, all what we have here will be the same thing as 3 raised to the power -2 multiplied by, let me use a dot to represent multiplication, multiplied by 1 plus 2x raised to the power of -2. All right? So this is what I wanted to explain that made me to use the previous analogy. Good. Now, this is what you now have to solve. Now, look at this. 3 raised to the power -2 multiplied by 1 plus 2x raised to the power -2. Now, you can easily solve 3 raised to the power -2. You don't need binomial expansion or any formula to do that because you know that 3 raised to the power -2 is the same thing as 1 over 3 raised to the power 2, which is the same thing as 1 over 9. I'm sure nobody argues with that. This is easy to solve. This is the one now that needs the use of this formula. And we can now use this because it has been conformed to the format that establishes this expansion. So we can go on now to have 1 plus 2x raised to the power -2, then 1 plus 2x raised to the power -2. So what you have to now do in continuing in this solving is that you go on now to use this format, this expansion, to resolve 1 plus 2x raised to the power -2. That because you can see it follows this format. You go on to apply this with this format, and then you will now be able to multiply the final answer. Whatever you get as this final answer, you will now multiply every of the content with 1 over 9. Because don't forget, 1 over 9 was supposed to multiply this expansion. That is the way you solve this. So we're going to get into this using this formula very soon. But before we get into using this formula, let's quickly try and let's do more of how to conform expansions that don't have 1 as the first value to format like this. So let's do that first before we come back. We'll come back to trying to make use of the formula. Please, can you indicate if you're following me and if you truly understood what I said? So we were able to establish this already as 1 over 9 raised to the power 1 plus 2x raised to the power minus 2. All right? Can you please indicate if you could follow me, you understood what I just explained? All right? Okay. Now, let's try and solve for this second one. Look at this second one now. That's good. I love that you can really flow. For this second one now, look at it. I want you to try it yourself while you also watch my own answer. So you can try and solve. Tell me what your final answer will be for this second example. So we have 2 plus 10x raised to the power minus 3. Look at it. If I want to make this conform to having the first value as 1, I have to bring out 2. I told you, just bring out that first value. Whatever was not 1, bring it out. The rest you have to find a way to conform the rest. So bring out 2 here, because 2 is what is not looking like 1 there. And then you'll be having 1 plus. Now, lucky us for this question. This question is quite having a perfect factor. So this will be 1 plus 5x. Now, that is that. Don't forget, I told you, you do not go on to write minus 3 here. That will be so wrong. So wrong. You have to bring this whole thing, the whole thing, into minus 3. All right? Now, this will obviously yield 2 raised to the power minus 3. Then you have 1 plus 5x raised to the power minus 3. All right, you see the way we established that already, the splitting of the expression mathematically. So this will be obviously 1 over 2 raised to the power 3, then 1 plus 5x raised to the power minus 3, which will finally give you 1 over 8, then 1 plus 5x raised to the power minus 3. How many of you got this as your answer? How many of you got this? If you know you got this, okay. Okay, all right, that's great. So, okay. Aduaka, did you get this? Okay, okay, that's nice. So obviously we have 1 over 8, 1 plus 5x raised to the power minus 3. Good. So that's quite nice. This is good. I believe you are able to flow with this, right? Inspired mind, that's good. Now, let's rush through some quick questions, and you are able to let's see how you tackle it very quickly. So let's start with this. So we're going to do it very quickly. I'm going to give you like 5 different examples now, and then you're going to give me the final. You can start with what we have on it, right on the board. Start solving. I didn't say you should get the final solution. Just give me the final form that will be able to conform to this formula. So let's just do these three. So let me give you the chance. Let me give you like 1 minute. I want you to have speed in whatever you're doing at this point, since you know exactly what to do now. So I don't need to do much. I want to confirm these three things because obviously none of them has okay, let me write this as a final question here. Because if you look at many of them, rather now, we have not all of them having 1 as their first value, which is the criteria to use this formula. You have to conform them to have 1 as the first value. So what do I do? As I explained already, the first thing is to bring out the 5 in the first question. So I'll be left with 1 plus 5x. Now, don't forget, I do not put the minus 2 here alone. I have to put all of them into minus 2. So this will be equals to obviously 5 raised to the power minus 2, then 1 plus 5x raised to the power minus 2. This will be 1 over 25 because 5 raised to the power 2 is 25. Then 1 plus 5x raised to the power minus 2. How many people got this? The first question. The first question, this is the first. This is what you are going to be solving. Of course. Okay, good. I like that. This is the one you'll be solving now using this formula. This 1 plus 5 because you have made it conform now to having 1 as the first value. Okay, this makes sense. Let's go to the next one. Give me your answer for the next one so that you can, let me see your answers before I do it myself. Give me your answers for the second one quickly. Do you have an answer already? Okay. So okay. All right. So let me do it since I have an answer. Let me do it quickly and let's see where we get to. So I bring out 2. Then I have 1 minus 3x raised to the power. Now, never doing that. I have to put everything raised to the power minus 3. So this will obviously produce 2 raised to the power minus 3. This will produce 2 raised to the power minus 3. 1 minus 3x raised to the power minus 3. This will be 1 over 8 because 2 raised to the power 3 is 8. 1 minus 3x raised to the power minus 3. How many of you got this? Okay, so that is us. We've been able to solve 2 out of 3. Okay, that's good. We've been able to solve 2 out of 3. Let's solve the third one there. That's this. Of course, I bring out 3. Then I have 1 minus 3x. Now everything must raise to the power minus 4. Everything. Always note that. So this will obviously be 3 raised to the power minus 4. Then 1 minus 3x raised to the power minus 4. This will be 1 over, what's 3 raised to the power 4? 3 raised to the power 4 is 81. Then that will be 1 minus 3x raised to the power minus 4. You can see how quite simple this is. All you need to do is just follow the step and you will never go wrong. Good. Now, that is nice. Let's now go on now. What's the answer for this one, by the way? The fourth question. What's the answer for the fourth question? What's the answer for the fourth question? Are you thinking that the answer for the fourth question is the same thing? you are supposed to produce the same, it's going to be the same thing because this is already conformed already. So we don't have to do anything. It's going to be the same 1 plus 7x raised to the power minus 5. This is conformed already. All right. So you don't have to do nothing there. All right. So we have been able to establish the rule on solving these questions. All right. Is everyone following and flowing with us? Now, I want to take you now to some other aspects of binomial expansion with negative power that is more technical. I'm going to write some questions and we're going to try and solve them. So let me use these three to try to explain something. This is the part that mostly confuses many students. The part where, look at what's going on here. You do not have perfect factors where you factorize something and then everything comes out very beautiful, like the one we just did some minutes ago. Now we have 2 here. So one of the issues many students will have is if we bring out 2, of course, that was going to be essential. I told you in any of the questions, either with perfect factors or without perfect factors, the best and the most feasible way of moving is for you to bring out 2. The initial, whatever is not conforming to 1, you bring it out because that's the only way you're going to be able to make that value 1. If I don't bring out 2 here, I cannot make the first value 1. So I have to bring out 2. Now, that's the easy part. Of course, if I bring out 2, I'll be left with 1 minus, that's the place where you have to be mathematical and sound and be intelligent to know how to get the next one. Because in this case now, you don't have a perfect factor. It's not like you had 4. If I had 4 here, I would have written 2x. If I had 4, if it was minus 4x. So how do you solve questions like this? Please pay attention. The first thing you have to do is what I have done already. You bring out the values that you want to conform to 1 and you make it conform to 1. This second part now, what do you do? I have, of course, in the first question, I have minus x, which is the same thing as minus 1x. If I bring out 2, what can I put here that would make, of course, something x that would make my expression the same thing? That I will have 2 minus x. This is 2 minus x. What can I put here? That when I go on to try and multiply 2 times 1, of course, 2. 2 times what will give me 1? Because in this case, now is 1 that is my issue. So 2 times 1 is 2, obviously. 2 times what will produce 1? Because, this is 1x. I'm sure you can follow. 2 times what? So let me say 2 times y equals to 1. That's like the one of the easier way of even solving your problem. Just say 2 times what? The meaning of this y here is like, what is 2 times what gives you 1? 2 times what? So for you to know that thing, which is what we are looking for, 2 times what gives me 1, because 1 is the thing we are looking for here. If you go on to solve this problem, you'll see that our y will be equals to 1 over 2. So it is very correct if I go on to fix this place as 1 over 2. Now, try and expand this and see if you are wrong or not. 2 times 1, 2. 2 times 1 over 2. If you go on to expand this will be 2 times 1, that will be 2, minus 2 times 1 over 2x. Is it not the same thing? Have we not been able to come back here? So you can see how to solve questions like this. So it's that easy. This is just because it's the initial question. When you solve more questions on it, you will see how simple it is. So this is the way you do this. So obviously, all I needed to write was 1 minus 1 over 2x. Of course, as you all know, the whole of this must be raised to power minus 5. And then you will now go on now to do the same thing we have been doing, which is for us to say 2 raised to power minus 5, then 1 minus 1 over 2x raised to power minus 5, which will be 1 over 32, then 1 minus 1 over 2x raised to power minus 5. So this is what you'll be solving. If you wanted to solve that question, you would solve for this 1 minus 1 over 2 raised to power x using the formula we have right here. All right. Now, let's solve the next one. You will see how easy it will get. Of course, the initial is always coming a bit like, since it's the first time you are probably being exposed to it. But when you solve more questions, you will see how easy this is. So I told you already, if I want to solve this question number 2, solving question number 2, I don't have to disturb myself. I told you already, when you have the first value not being 1, it is that value that was not 1 that you first bring out. It's not questionable. That first value must come out. So in this case, I will have to say 3 into bracket, because I know that's the only way I'll be able to get 1 minus, don't forget, what we're trying to do here is to ensure that our expression conforms to the first value being 1. Any other thing can happen next. It can be minus 5x, can be plus 3x, can be anything. But that first value must be 1. So we have to bring out, in this case now, 3. Now, the question is, the same way I asked that question, 3 times 1, 3. 3 times what? Of course, we have 3 times what will give me minus 5. Like 3 times what will give me minus 5. Or let me say 3 times minus what, because in this case now, we are having, if you can say it in different way, you can either say 3 times this gives me 5, or 3 times minus this gives me minus 5, anyhow you want to say it. So what do you multiply 3 with that will produce 5? What do you multiply 3 with that will produce 5? Now, using what do you multiply 3 with that will produce 5? If you use your normal, the normal perfect examples, you may not be able to easily get something that, because there is not, 5 is not a multiple of 3. So you cannot say 3 times 2, 5, 3 times 5. No, 3 cannot have a perfect a multiple. That 5 is not one of the multiples of 3. So that's why we have to use this expression I said. So we'll say 3. Of course, I don't need to do this, by the way. I'm doing this just because for everyone that probably need a logical method to always solve it. So 3 times what? Let me put y there. 3 times what? 3 times what? Or let me say 3 times, let me just say 3 times what gives me 5. Let me use it that way. 3 times what gives me 5. So if I wanted to, 3 times what gives me 5. So let's see. If 3 times what gives me 5. That means my y here is equals to what? 5 over 3. I'm sure you know how to solve it. If I wanted to solve it, I would say divided by 3, divided by 3. That means my y was 5 over 3. So that means if I write 5 over 3 here, 5 over 3. Let's see if this is correct, because it's not something you, yes, I love that I'm seeing the answers. Exactly, I love the answers I'm seeing. You don't have to be, you don't have to just hit your head on the wall. If you have done something wrong, you can easily find it out, because whatever I did here must always give me whatever is within here. It must always. So let me try and open this expansion and see if I'm getting 3 minus 5x. If I don't get 3 minus 5x, then I'm wrong. So 3 times 1 is what? 3. 3 times 5 over 3. What is it? 3 cancel, that's 3 minus 5x. It's perfect. That means this answer is correct. Simple. So that's the way you solve, that you will never go wrong. So obviously now, this is the way you can see how we are able to move from here to this place. Now, do not forget, we have the general power of minus 3. All right, minus 3. So if we have the general power of minus 3, we obviously know that, as I said earlier, we will now have 3 raised to power minus 3, then 1 minus 5 over 3x raised to power minus 3. All right, then you go on to have 1 over, okay, 3 raised to power 3 is not nice, 27. Then we have 1 minus 5 over 3x raised to power minus 3. So this is what you are going to be solving. Of course, you use this formula to solve this one, and then whatever you get as the answer here, you multiply with 1 over 27. That's how simple and easy this is. So don't forget, I'm going to give you your homework to do in some minutes time, but let me do the last one here, that you can use this as your last opportunity to know it. Then you'll be solving yours any moment from now. So look at what we have. 3 plus 2x raised to the power of minus 2. Now, again, I told you the very first step is that you go on to bring out the first value, because it is the first value you want to conform to 1. So go on and you have 3 into brackets. That's the first thing. Then you'll be having 1 plus, now, something x. I do not know what that something is, because 3 times what will give me 2. That means if I try to open 3 times what will give me 2. That's the question I want to ask. 3 times what? Look at it this way. 3 times, I used to use y. 3 times y, that's what. The y here is representing what. 3 times what will give me 2. Of course, my y will be 2 over 3. So it is okay for me to write 2 over 3 here. Now, that is, you can see how faster we can get now when you already know what you are doing. So if you want to always confirm your answer, am I correct, am I not correct, go on to expand what you have, to go on to solve what you did. You factorize 3 out and you add this inside. Go on to open it. Let's see if it gives you the same answer. 3 times 1 is 3, plus 3 times 2 over 3. That will be 3 times 2 over 3x. Of course, 3 will cancel 3. You will be left with 3 plus 2x. So that means this is perfect and this is correct. So that means the final answer here will be 1 plus 2 over 3. And then don't forget, we'll be having all this raised to the power of minus 2. All right. So let's quickly now get into your own work, because it's very important that you also make your own attempt. All right. So let's see. You can start solving immediately. You don't have to wait till I write all the questions out. Your first one will be 3 plus x raised to power minus 6. That's the first question. What is the answer? Let me have it. Number 2, let's have 4 minus 3x raised to power minus 4. And let's have the third as 5 plus 7x raised to power minus 2. And let's have the fourth as 4 minus 3 over 2x raised to power minus 3. And let's have the fifth as 5 minus x over 2 raised to the power of minus 5. These 5 questions, once you are able to successfully solve these 5 questions, I don't believe there is any question out there that should pose as a challenge under binomial expansion with negative power. So start cracking it and have your answers. Then I'll be asking for it, or we'll solve together, and then you will tell me if you got the same thing. So the first question, if you are done, just give me your answer. Don't wait for nobody. Just send your answer quickly. Once you are done, let me know. All right, answers. Do I get my answers now? Where are my answers? Okay. Okay, that's for the first question, I guess. Okay, good. Let's solve that. Please, I want responses so that we can flow together. Please, I want everyone to give me their response. Everyone, please, let me get your response so I know that you are flowing with the class. So let's try and solve the first one. We have 3 plus x raised to the power minus 6. Obviously, I told you the first step is you have to bring out the first value that you want to try and conform to 1. When you bring that out, of course, you would have 1 plus. Now, to know what you're going to put here, the question is to ask yourself, 3 times what will give you, of course, in this case, there is 1 here. So 3 times what will give you 1? 3 times y will give you 1. Y will be equals to 1 over 3. So that means here we'll be having 1 over 3. You can go on to confirm that, but I will not be doing that because I know this will be correct. This will be everything raised to the power of minus 6. So this will be 3 raised to the power minus 6, then 1 plus 1 over 3x raised to the power minus 6. Of course, this will be 1 over 3 raised to the power 6, and 1 plus 1 over 3x, everything raised to the power of 6. All right. So 1 over 3 raised to the power 6, that should give you about, I think, 729. So the final answer there will be 1 over 729. Then all this. How many of you got this? What's your response for this? Were you able to follow this? How many people got this answer? This particular one for this first one, please. I would like your responses. How many of you got this answer? Okay. You are still solving. Can you indicate if you are still solving? Okay. If you are still solving, can I know? Can you inform me? Okay. All right. So let's solve the next question right there. So we have the next question, and we have 4 minus 3x raised to the power minus 4. All right. Now the very first value that we have 4, and then you have to have 1 minus. Now what you don't know, what are we going to have here? So I told you this, the most logical approach is just to say 4 times what gives me 3, because 3 is what you're looking for. 4 times what gives me 3. I mean, y equals to 3 over 4. So of course I want to just have 3 over 4 here. All right. And then we go on to have all of this raised to the power of minus 4. So obviously that will be, as I said already, you'll be having 4 raised to the power minus 4, then 1 minus 3 over 4x raised to the power minus 4. This will obviously be 1 over 256, then 1 minus 3 over 4x raised to the power minus 4. You got this? Can I know? How many of you got this correctly? Okay, let's move on to the next question. The next question we have to factorize 5 out, then we have 1 plus what times x. So that means 5 times what? 5 times what will give me 7. Of course, y will be equals to 7 over 5. That will be 7. Can you see how simple this gets? Right? You can see how simple this gets when you are able to understand the concept. So that will be everything now will be raised to the power of minus 2. All right, so this will be 5 raised to the power of minus 2, the 1 plus 7 over 5x raised to the power minus 2. This will be 1 over 25, 1 plus 7 over 5x raised to the power minus 2. So that's the way you solve all these things. Very, very easy. So there's no difficulty at all. So let's try and solve the next question there. The next question there obviously is we have to, I told you already, the concept is that you have to bring out the first value. So without compromise, let's bring out the first value. The first value will obviously be 4. That will be 4, 1 minus what times x. So 4 times x, 4 times what gives me 3 over 2. 4 times what gives me 3 over 2. 4 times what gives me 3 over 2. It's the same question you've been asking, you would ask. So y will be equals to 3 over 2 divided by 4. You know, I'm dividing through by 4, dividing through by 4, right? So y will be equals to 3 over 2 divided by 4. That will be y being equals to 3 over 2 times 1 over 4. That will be 3 over 8. So can you see this now? It's very, very vital. Very, very vital that you are able to follow this format. You see how this helped me, you know, if you're not very sound or even a common man, it's actually going to be hard for you to know that the answer here would have been 3 over 8. You see that? But using this logical method, by asking yourself 4 times what gives me this, you can see how easy and straightforward we're able to get the answer, right? Good. Now, because of the sake of this, how this looks like, let me try and expand and let's see if our answer is correct, so that at least we're able to confirm if these answers are actually correct. So let's try and do this. Let's try and expand. Let's try and solve this. 4 times 1 will be 4. Then minus, we have 4 times 3 over 8. All right, so let's try and see if this is correct. Of course, 4 goes here, 1, 4 goes here, 2. That will be 4 minus 3 over 2x. Can you see? Correct. So we are good to go. You can see how this works very well. So now don't forget, we have raised to the power of minus 3. Not just this one, but everything. As I've often said, raised to the power of minus 3. That will be 4 raised to the power of minus 3. And that will be 1 minus 3 over 8x raised to the power minus 3. So this will be 1 over 4 times 4 times 4 will be what? 16 times 4, that will be 64. So that will be 1 over 64. Then multiplied by 1 minus 3 over 8x raised to the power minus 3. Can you see how easy and straightforward it gets when you know and you follow the right method? So let's see the last but not the least question there. Of course, we have to bring out 5. Then you have left with 1 minus, then I ask the same question. I don't know what will be here, but I just know following the logic will give me my answer. So I ask myself, 5 times what gives me, in this case, don't forget this is 1 over 2x. So I will say 5 times what gives me 1 over 2, because this is x over 2 is the same thing as 1 over 2x. I'm sure you understand that. So this is 5 times what gives me 1 over 2. So y here will be equals to 1 over 2 divided by 5. Now be, imagine I was dividing, not imagine, this is actually what I'm doing, dividing both sides by 5. Now we 5 will cancel 5, it will be left with y equals 1 over 2 divided by 5, which is y equals to 1 over 2 multiplied by 1 over 5, which will be 1 over 10. So that means the answer here is 1 over 10. All right. Now, because of the complexities involved in this problem, I would love to expand it so we confirm our answer. So this is 5 times 1, 5. This will be 5 times 1 over 10. This is 2. That will be 5 minus 1 over 2x, which is the same thing as this. So obviously, you do not want to leave your answer just as this. You want to ensure it reflects the power, which the power was minus 5. And you have 5 raised to the power minus 5. Then you have 1 minus 1 over 10x raised to the power minus 5. 5 raised to the power minus 5 will be 5 times 5 times 5 in 5 places. And that gives me what? That gives me a value of 3125. So that will be 1 over 3125. That'll be 1 over 3125 and 1 minus 1 over 10x is to the power minus 5. So this is how we solve questions of this sort. How many of you are following, you enjoy what we're doing, and you are able to relate? Please, can you indicate that you have perfectly understood this? Like you really understand what we're doing and it makes so much sense. How many of you can really give me that feedback? Because we're done with the major aspects on this. Now the next thing to do now is to go on now to bring all these things, solving using this formula. All right, but let me hear your feedback first. How do you feel? Okay. I like that. I like it. I like the responses I'm getting. All right. I like that responses. That's exactly the reason why we're here, so that we're able to understand. Now that we've been able to resolve all these major aspects of this, we can now go on. The next is fluent. Once we're done with once you really understand all these things, the rest is very fluent, I can assure you. So I will solve about 3 different problems, and I would hope to give you some to solve, and then I would hope that would make this perfect. All right. So I cleaned that up, but I need to always add it there. I wanted to add it much properly. As I told you already, it's very vital. You always define the values for hex that makes that on which your function is defined on. Now let's solve the very first question now. Now that you've understood all this, let's now go on now to solve the very first question. All right. The very first question is this. We're told to find the four terms. Find the first four terms of this. Let me write the expression here now. We have 2 plus 10x raised to the power of minus 2. 2 plus 10x raised to the power of minus 2. All right? This is the question. Now, let's start. I'm sure you understand exactly what we're to do. The first thing now, because you can see that the first value here is not 1. So we have to go on to conform this to look like this format. So this obviously 2 plus 10x raised to the power of minus 2 will be equals to, I bring out 2, and I have 1 plus 5x raised to the power of, everything now will be raised to the power of minus 2. This will be 2 raised to the power minus 2, 1 plus 5x raised to the power minus 2. I'm sure everybody understands what I'm doing right here. So I have this as 1 over 4, then 1 plus 5x raised to the power minus 2. This is what we just finished doing over the last about 1 hour. Now, this is good. Now that you are done with this, the next thing to now do is that you need to note one thing. At no point do you throw away this 1 over 4. This 1 over 4 is multiplied by all this. The solution to this question is 1 over 4 times the answer to this. Please don't forget that. The solution to this question is not just 1 plus 5x raised to the power minus 2. It is the multiplication of 1 over 4 with 1 plus 5x raised to the power minus 2 that gives you the perfect solution to the question you are given here. So make sure you never ignore 1 over 4 here. Make sure it's always side by side. So this is it. I'm going to write out 1 over 4 here. Then I'm going to open a larger bracket. Now, what am I going to use this larger bracket for? I'm going to use it to give the solution for 1 plus 5x raised to the power minus 2. And don't forget, I'll be using this format that I have right here. So this conforms to this format. This is 1. Then I have my x here being given as 5x. Please note that. So wherever you see, remember that was one of the first things I started with in this class. Wherever I see x in this expansion, I'll be writing 5x now, not x. Because whereas in this case I had x, in this case I'm having 5x. All right, good. So what do? The first thing I'm trying to solve 1 plus 5x raised to the power minus 2. Also, I need to also bring to your notice that your n is what here? Your n is minus 2. So wherever you see n in this expansion, you'll be putting minus 2. Wherever you see x, you'll be putting 5x. Note those two things. That's what the only thing we're going to be doing is to insert n as minus 2 and x as 5x into this expansion, and that we're good. Don't forget, we are told to find the first 4 terms. 1, 2, 3, 4. So what I have here will be okay for this question. So the very first term is 1. That's the first term. I write that. All right. The second term is plus. Now I have n times x. Now my n is minus 2. That will be minus 2. My x is no longer just x, but 5x. 5x. Can you see that? So that's the second term. I'm done with the second term. Let me do the third term now. The third term, this is it right here. My n is what? Minus 2. So I have minus 2 times this minus 2 minus 1. What is minus 2 minus 1? Minus 2 minus 1 is minus 3. So I have minus 3. Then I have over 2 factorial. Now, my x is not x. My x is 5x. So I have 5x raised to the power of 2. You can see the way I wrote my 5x because this is a compound expression. You have to use your bracket. So in this case, there was no bracket because it's a singular expression, just x. So x is x everywhere. But this 5x, I cannot go on to write 5x squared. I have to write 5x, everything raised to the power 2. All right. Now, that's the third term. I'm done with the third term. Let's see the fourth term here, which is the last term where we're going to stop. The first value here is n. That will be minus 2. The second value is minus 2 minus 1. That will be minus 3. The third value is minus 2 minus 2. Minus 2 minus 3 is minus 4. Can you see that? Then everything over 3 factorial. Then x raised to the power 3 was here, but we are going to be writing 5x raised to the power of 3. This is where we're going to stop. Of course, it goes on and on, but we are just finding the first 4 terms. So this is what we are left with now to solve. So once you have gotten to this place, the only thing you need to do now is for you to use all your mathematical knowledge to make this perfect. What do you want to do? Of course, you have to make sure you ensure your 1 over 4 is still here, because at the end of everything, we'll be using 1 over 4 to multiply everything inside this bracket. So the first value is 1. Minus 2 times 5, that will be minus 10. So this will obviously change from plus, because minus 10 times plus will be minus. That will be minus 10x. All right. Now, minus 2 minus 3 is what? Minus 2 minus 3 times minus 3 will be 6. And what is 2 factorial? I'm sure you know what factorial means. Factorial is just 2 factorial will be 2 times 1. 3 factorial will be 3 times 2 times 1. I'm sure you know that, right? So this is minus 2 minus 3. That will be 6. That will be 6 over 2 times 1. 6 over, I would not, because of space, I will just write 6 over 2. Then I will go on to try and solve this. This will be 5 raised to the power 2. That will be multiplied by 25x squared. Then let me write the plus. So I'm sure you'll follow what happened here. Minus 2 times minus 3 is 6. Then 2 factorial is 2. Then 5 raised to the power 2 x squared. That will be 25x squared. All right. Good. Now, what about this last one? Minus 2 minus 3 times minus 3. That's 6. 6 times minus 4. That's minus 24. Minus 24 over what? 3 times 2 times 1. That's 6. Then here we have 5 raised to the power 3. 5 times 5 times 5, that's 125. So that will be times 125 x raised to the power 3. Plus dot dot dot, which we are not so much interested in based on this question. Now, I don't want to have to write this all over again, because, or do I have to do that? Probably let me just shift the camera to adjust a little bit so we can use the space down to solve this much properly. So we have 1 over 4. Then I have 1 minus 10x. This will be 2 will go in 6, 3. 3 times 25 will be 75. That will be 75. That will be 75x, I believe. What is 3 times? Okay, so that will be 75 plus 75x squared. And this one we have here, this will be 6 going minus 24. That will be minus 4. Minus 4 times 125. So if you have 4 times 125, that will be 500. So that will be minus 500. Of course, that will be minus 500 x3. All right. You can see how we're able to solve this question very smoothly. That's what happens when you solve using the right method and you don't make any mistake. Now, we are almost done. We are at the last end of the answer to this question. So the next thing for us to do now, probably I can still use this space down. So the next thing for us to do now is to multiply this 1 over 4 with every value inside this bracket. So that will be 1 over 4 times 1. That will be 1 over 4 minus 10 over 4. I'm sure you can see minus 1 over 4 times 10 will be 10 over 4x. Then 75 divided by 4. X squared. I'm sure you agree with that. What is 500 divided by 4? 125, right? That will be minus 125 x cubed. Now, can you see? And that's our answer, by the way, just so you know. This is the answer. So, find the first 4 terms of this expansion. This right here is the answer. That's the first 5 terms. Sorry, the first 4 terms. 1, 2, 3, 4. All right? Now, but do not forget, I told you something. That you must always state the value, your x, on which your expression is defined. That makes your expression defined. And I told you this is it right here. So for this case where we had x, we used x. But when we have, in this our own case, we were not dealing with x, we're dealing with 5x. So I told you what you have to go and do is to fix same 5x. So you'll be having 5x less than 1 less than minus 1, just like this. So, of course, you have to go on to solve for x. That will be minus 1 over 5 less than x less than 1 over 5. So you have to always state this at the end of your expansion. All right? That's how simple this is. So this is how you can see how we're able to solve this question without making any mistakes. Now, let's go on now to solve another one. If this wasn't clear, of course, you know the next question will be clearer. So the same field, let's do with the same field. 2 plus 10x raised to the power of minus 2. All right, so let's do this. Now again, I'm sure you know the first steps are very easy because we have done that one. We took a while to do that. So we have 2 plus 10x raised to the power minus 2. What do? We bring out 2. We have 1 plus 5x, everything raised to the power minus 2. So we have 1 over 4, 1 plus 5x raised to the power minus 2. Simple. This is the first thing we have to do. Now, we have done this for some while now in this class. So let's go on now to establish the other parts. Now that we have been able to conform this to this, of course, you have to bring out your 1 over 4. Very important. It looks funny that the first question I think had 1 over 4. This one is also having 1 over 4. Or because we had 2 as the starting and we were raising them to the same power of 2. Oh, we're solving the same question. Sorry, this was a wrong. I wasn't supposed to solve this. I was just surprised that why this was not the question I intended to solve. Sorry, I'm supposed to solve 3 plus 6x raised to the power of minus 2. I was just wondering why are we having the same 1 over 4. All right. So we have 3 plus 6x. Let's do this. 3 plus 6x raised to the power minus 2 will be equals to 3, 1 plus 2x, then everything raised to the power of minus 2. Then we have 3 raised to the power minus 2, 1 plus 2x raised to the power minus 2. So this will obviously be 1 over 9, then 1 plus 2x raised to the power minus 2. All right, good. Now, what do? We obviously have to bring out our 1 over 9 and lay a big bracket, which will occupy 1 plus 2x raised to the power minus 2. So let's try and solve this using, of course, the formula. So the very first term for this formula is 1. So we have to have 1. That is non-negotiable. The next term is nx. In this case now, our n is what? Our n is minus 2. So that will be minus 2. And what is our x? Our x here is 2x, not just x. Our x is 2x. So that will be 2x. Please, I would love you to solve this alongside me so that you are able to familiarize yourself. I would love if you are even flowing ahead, even before I would love you to flow ahead even before I'm done. You have gone ahead, so you are able to relate to what I'm doing. All right. So now we have, this is the second term. This is it right here. So the third term, we had n times n minus 1. What is n times n minus 1? Our n is minus 2. That will be minus 2. N minus 1 will be minus 3 over 2 factorial, which is 2. Our x is 2x, so we'll be having 2x raised to the power of 2 plus, so here we have minus 2, minus 3, minus 2 minus 2, that's minus 4. And everything raised to the power 3 times 2, that's what? Let me just write it as 3 times 2. Not 3 times 3, 3 times 2. All right. And then our x here is 2x. So we'll be having 2x raised to the power 3. And then let's just leave it there. On and on and on. All right. I have to close my big bracket. So I have 1 over 9. Right? And the first term is still 1. 1 plus minus 2 times 2x. That will be what? Let me manage this space properly. Let me have it as 1 over 9. Then I have 1 plus minus 2 times 2 will be minus 4. Minus 4x. Minus 2 times minus 3, that's 6. 6 over 2 is 3. That will be plus 3 times 2 raised to the power 2. That will be 4. X raised to the power 2. Then plus, I'm sure you can flow with that. This is 6 times minus 4, that's minus 24. Minus 24 over 6. Then we have 2 raised to the power 3, that is 8 times 8, x raised to the power 3. You can flow with what I'm doing. I'm just solving mathematically. Minus 2 times minus 3 is 6. 6 times minus 4 is minus 24. Then we have this. Then we have 2 raised to the power 3, 8, and on and on. So let's try and fix this up. 1 over 9. 1 minus 4x. This will be 12x squared. This will be minus, this is minus 4. Then times 2, that will be minus 32. X raised to the power 3. Then we have, and so on and so forth. All right. So what are we doing next? What we're doing next now is to multiply everything inside this, our big bracket, with 1 over 9. So 1 over 9 times 1 will give me, obviously, 1 over 9. 1 over 9 times 4 times minus 4 will be minus 4 over 9 x. 12 over 9, which will resolve to 4 over 3. I'm sure you know why, because 3 can go in 12 and 3 can go in 9. 4 times 3 times x squared. Then we have 32 over 9 x cubed. Then we have on and on and on. All right. So we are almost done. Now, the last thing, actually, this is the end of the expansion, but the last thing you want to do, as I said already, which is very vital, is you want to define your x. So your x now here was not, don't forget, your x is not 6x, so your x is this one, which is 2x. So you're not using 6x, you're using the 2x, which is what you solved. You know, this was what you solved. So your x here is defined on 2x. So 2x less than 1, then greater than minus 1. That will be minus 1 over 2 less than x less than 1 over 2. So this is the bandwidth for which your x will be defined on. All right. Is this clearer? How do you feel about it? So we have one last question to solve before I throw questions at you. How do you feel about it? Okay. It's clear, Abba. Good. That's nice. That's good to hear. Okay. So this is how you solve binomial expansion with negative power. Quite very simple and straightforward. So I want to give you one last question, then you would have your own questions to solve. So in this case, we are solving for the first just 3 terms. And this is the expansion we're dealing with. Look at what you are given. 1 over 5 minus 3x raised to power 4. This is the question you are given. You have to find the first 3 terms. Now, anyone that sees this question may be confused if you don't know some basics in mathematics. So what basics do you need to know for you to be able to enjoy this question? You need to remember that when you have 1 over 2, we say 1 over 2 is the same thing as 2 raised to power minus 1. Of course, because 1 over 2 is the same thing as 1 over 2 raised to power 1. If you have 1 over 2 raised to power 2, we say the same thing as 2 raised to power minus 2. If you have 1 over 2 raised to power 3, we say the same thing as 2 raised to power minus 3. So the same thing goes here. That if we have 1 over 5 minus 3x raised to power 4, it's going to be the same thing as 5 minus 3x raised to the power of minus 4. All right? So don't always expect that you'll be given the question straight. You may have questions of this form. So you have to find a way to conform it. Now, conforming this to this answer now, you can see that it has produced the value that has a negative power. Now, I'm sure you recollect that this is just another aspect. We have the aspect where we could have a positive power, which has been explained on this channel. I believe we have videos on that already. Now, but for the one of negative power is what we're trying to resolve in today's class. So now that we've gotten to this part, we have to now go on now to solve using the format we just explained. So we have 5 minus 3x raised to the power minus 4. 5 minus 3x raised to the power of minus 4. All right, good. What do we do next? This is like that aspect that don't have perfect factors. But you know the first thing to do is to bring out 5 and you're left to 1 minus. Now you ask yourself, what's 5 times what gives me 3? 5 times y gives me 3. Y equals to 3 over 5. So obviously this will be 3 over 5. All right. So and all of this will be raised to the power of minus 4. So obviously this will give you 5 raised to the power minus 4. Then 1 minus 3 over 5. Sorry. Let me take this out. So this will be 1 minus 3 over 5 raised to the power x raised to the power minus 4. What question do you ask how to? Somebody asked the question of how. What are you asking about? Is it this you have? What are you wondering? Probably you would find an opportunity to check back on the video and understand what or are you trying to ask how we got 3/5 here? Of course, we have done several questions. Maybe you joined this class late. Yeah, 3/5 is, we've done several questions on it. You probably will have to get back to that. We solved almost close to 10 questions on this type. It's quite very simple. You just need to go back. All right. So if you go back, you would see how simple that is. Now, this is 1 over, what is 5 raised to the power 4? 5 raised to the power 4 will be 625. Then we have 1 minus 3/5x, everything raised to the power of minus 4. So now, this is what we want to solve now. So this will be, of course, the first thing we're going to write, 1 over 625. Then we'll open our big bracket and we go and solve for 1 minus 3/5x raised to the power minus 4. So in this case, now you can see that your n is minus 4 and your x is minus 3/5x. So you see how you follow the same format. You don't have to do anything different. So your x now will not be x. Your x is obviously minus 3/5x. And your n is minus 4. So you go and fix that in this format, because if you look at this format, this is 1. This plus x now is minus 3/5x. And your n is minus 4. So wherever I see n now, I want to put minus 4. That will be 1 plus minus 4. Our x will be obviously minus 3/5x plus, then we have minus 4, because our n is minus 4, multiplied by minus 5 then we have our x now is not just x, don't forget, it's minus 3/5x. We're going to have minus 3/5. You see the way I write this, x all square. Now, in this case, we're only interested in the first 3 terms. So, first 3 terms. So, we're not going to be using this last one. We're using just the first 3. All right. So, we're going to be stopping here. So, look at exactly what I did here. I know that my x is minus 3/5x. You can see wherever I saw x, I'm putting minus 3/5x. That's it right here. You can see right here also. That's what you just need to follow that and you will never go wrong. And wherever I saw n, I'm putting minus 4. Good. So let me try and resolve this now. So I have 1 over 625. And I have 1 plus. If I try to solve this, this will obviously be 12/5, because minus 4 times minus 3 is 12, plus 12, because minus times minus is plus. So that's 12/5x plus, this is 20/2, right? 20/2 will be what? 10. That will be 10 times minus 3/5 square. That will be minus 3/5 square, then x square. Look at it. What I'm doing here is step-by-step process. I don't want to go wrong. So I have minus 4 times minus 5. That's 20. 20/2. That's 10. That's how I got this 10. For this one now, I have minus 3/5 square. That's it right here. And x square. That's it right here. Good. Now, if I want to solve minus 3/5 square, how do I solve that? That means minus 3/5 square. What's it going to be? That will be 9/25. I'm sure you understand that. So that means I'll be dealing with what? Look at this place now. This whole thing now gives me 9/25. That means I have 10 times 9/25 times what? X squared. I'm solving this whole thing here now. 10 minus 3/5 square, I've gotten it as 9/25, then x squared. So what does this give me? This 5 will go here 2, 5 will go here 5. 9 times 2 is what? 18. 18 over 5. So this whole place will give me 18 over 5x squared. All right, so this will be 1 over 625, 1 plus 12 over 5x plus 18 over 5, right? X squared. And so on and so forth. So you can see how you have to just solve carefully and make sure you are not just mastering the technique alone, but you are able to always flow rightly. So everywhere you need to do your square, your multiplication, and every other thing, you do it promptly and rightly. Once you do that, you don't go wrong at all. So let me just put an equals to sign here. So I have this as 1 over 625. I open the bracket. Oh, okay, I don't have to do that, by the way. Let me start to open my bracket. That's the best thing to do here. So 1 over 125 times 1 will give me 1 over 625, not 125, 625. Then 1 over 625 times 12 over 5. That will be 12, because 12 times 1, that will be plus 12 over 625 times 5. 625 times 5 will be 3125. That will be 3125. What I'm doing here is I'm opening this bracket. So this times 1, this times 12 over 5, that's 1 times 12, 12, 625 times 5, 3125x, obviously. And then plus I have 18 over 5 times 1 over 625, which would be 18 over 3125. We do not have something that can go in, that can divide both 12 and 3125. So this will be my final answer. All right, quite very simple and straightforward. So this is the answer, the first 3 terms. This is the first term, this is the second term, this is the third term. But there's something I have not done yet. Can anybody identify that? There's something I have not yet done, which is that I'm yet to put, I'm yet to define my x. So let me go on to define my x right here. How do I define my x? Of course, my x here is, look at it, minus 3 over 5x. So instead of writing this x now, I'm writing minus 3 over 5x. Less than 1, less than minus 1. I've told you, all you have to do is just whatever was your, in this your second place that was for your x, you fix it here and you put your bandwidth as minus 1 and 1. Then you go on now to solve. You go on to solve this. Of course, you want to make x, you want to multiply both sides by 5 over 3, minus 5 over 3. Of course, to make this as x, you want to turn this whole thing to x. If you want to turn this whole thing to x, you have to multiply by the reciprocal of 3 over 5, which is 5 over 3, minus 5 over 3. So if you do that, you'll be having this, obviously. This will be your final result. Minus 5 over 3 less than x and less than 5 over 3. You can go on to solve it and you will see this is the answer. All right. So this is how simple this is. I feel there is no need to fret over binomial expansion with negative powers. I believe you can always be good at solving any question. It doesn't matter I think this came out in your exam, right? So the exercise I'm going to give you will actually be the same question you had in your exam. So you can go on now to attempt that question now. Let me write it for you. So you go on to attempt that question and let me see how you fare with that. So the question is for you to find the first four terms of 2 plus x raised to power minus 3. This is the question I would love you to solve and understand it properly. So can you make an attempt to this quickly? Let me give you about 3 minutes to solve that, and we'll be able to end the class with that. 3 minutes, can you solve that question? The first four terms. To ensure you just follow the steps and move appropriately, following all the methods we just went through in the past over an hour ago. All right, and let me get your answer. I believe the questions are very simple. Anybody with an answer yet? Quite funny because I think it's quite simple anyway. But so you see, negative binomial expansion with negative powers are quite very, very simple. I'm sure you all agree now at the end of this class. So all you need to do is just follow the steps. You cannot go wrong. So I do not expect you to miss any question as regards binomial expansion having negative powers at the end of this class. So can you attempt the question? I believe you are attempting it. If you're attempting it, can you indicate quickly? Let me know if you're attempting it. You're there, you know you're attempting. Just drop something and let me know you're attempting it. 2 plus x raised to power minus 3. All right, I'm sure you know the first thing to do. You have to make this conform to the first format. Okay, someone is on it. Can I get other responses? If you know you're on it. Okay, someone is trying there also. I can see that. Okay, who else is making an attempt to the question? Okay, I like that. That's good. Okay, that's good. That's good. Okay, that's good. Just let me get your responses. Okay, so the first thing you have to do is to conform this to the format I told you, the format for the formula, which is by bringing out 2, and you have 1 plus. In this case, now you're having 1 over 2x. All right, that's the very first thing, because then everything will be raised to the power of minus 3. This is the very first thing. So if you go on, you want to check this, you go on to open this. This is 2 times 1, 2. 2 times 1 over 2 will give you 1, which is what you're looking for, x. Right, so this is the first thing, and then the next thing is for you to have 2 raised to the power minus 3, then 1 plus 1 over 2x raised to the power minus 3. This will be 1 over 8 This will be 1 plus 1 over 2x raised to the power minus 3. All right, so this is this is the very first thing you must do. So you will be solving with 1 over 8 times all the expansion around 1 plus 1 over 2x raised to the power minus 3. So the next thing after getting here to do is to go on now to use the formula to solve for 1 plus 1 over 2x raised to the power minus 3. All right, so I'm sure you all got here first. So this is how you solve it. So we have 1 over 8. Then you now go on to give the expansion for 1 plus 1 over 2x raised to the power minus 3. Your n here is minus 3. As you can see, this is your n value. And your x is 1 over 2x as your x value. So the very first term is 1. The second term will be n times x. In your n here is minus 3. That will be minus 3 times what our x? Our x is 1 over 2x. All right. The next one, the next term we have n times n minus 1. That will be minus 3 times minus 4 over 2 factorial. That will be 2. Then our x is not x. Our x is 1 over 2x. That will be 1 over 2x raised to power 2. Good. We're done with the third term. The fourth term, we have n times n minus 1 times n minus 2. That will be minus 3 times minus 4 times minus 5. Everything over 3 times 2. That's 9. Sorry, that's 6. Then our x will be 1 over 2x raised to power 3. So this is where we're going to stop at because we're just looking for the first 4 terms. Right? So this is what you must be solving. If you have started solving, this must be in front of you if you are doing the right thing. So we have 1 over 8. Then we have 1 plus, this will be minus, of course, because minus, this will be minus 3 over 2x. Then this will be a plus. Minus 3 times minus 4, we have minus 3 times minus 4, we have 12. That will be 12 over 2. That will be 6. Then this will be 1 over 4 because 1 over 2 square will be 1 over 4. That will be times 1 over 4 x squared. Of course, this will give me 6 over 4, which will be the same thing as 3 over 2. So I'll write it as 3 over 2 x squared. Of course, I am trying to solve very fast. Okay. Good. Okay. It looks like people are giving me the response already. I like that. I like that. So this will be minus 3 times minus 4. That will be 12. 12 times minus 5. That will be minus 60. Minus 60 over 6. Then we have 1 over 2 cube will be 1 over 8. That will be times 1 over 8x cube. Plus on and on and on. So this will be minus 10, obviously. Minus 10. So that will be minus 10 over 8. So I can write this as minus 10 over 8x cubed. Plus dot, dot, dot. So that's the way you solve all these things. You don't have to ever miss a question on this. Okay, I'm not sure if I was correct with minus 10 over 8 because was I correct in this minus 10 over 8? Let me see. This is minus 12 minus 6. Sorry, minus 12 times minus 5. That's minus 60. Minus 60 over 6. That's 10. Okay, I think that's actually correct. So that will be minus 5 over 4. Right? Because minus 10 over 8 should give me, we can take this down to minus, this will be 5 because 2 will go here 5, 2 will go here 4. All right. So what do we go on to do? We expand using 1 over 8. That'll be 1 over 8 times 1 over 8 minus 3 over 16. Am I correct? X plus this will be 3 over 16. X squared. This will be minus 5 over 32 x cubed. Do you see that? How many of you got this answer? This exact answer? 1 over 8 minus 3 over 16x plus 3 over 16x squared minus 5 over 32 x cubed plus dot dot dot. Now, of course, you understand that you do not leave your answer like this. You have to go on to define your x. So your x here is what? What was our x? 1 over 2x. This was our x representation. So we have 1 over 2x less than 1 less than minus 1. So multiply both sides by 2. So we have a minus 2 less than x less than 2. So this is the value on which, the bandwidth on which your x should be defined on. So if you did this in your exam, this was what you wrote in your exam, you got your perfect mark. How many of you think you got this in the exam perfectly? You think you got this exact answer in your exam? And if you know you got this answer, you're very sure of yourself. Can you signify quickly? Nobody's talking. Okay. Well, how many of you agree that this is quite simple? You agree with me that this is quite simple. So if you know you have gained so much, can you okay. Okay. If you agree with me that this is quite simple, can you just give a shout out quickly on this video, because we're about to end the class. So of course, this is everything I'll be explaining on binomial expansion with negative power. All right. Okay, somebody said he did not attempt this question, of course. But if you had the opportunity, would you have attempted it now that you know it? Now that you know it, do you feel you regret not attempting it? Because this is okay, good. I like that. Okay, it's simple, good. Okay, okay. That's nice. So that means I think this has been productive, this has been effective. As long as you are able to get the whole concept, then that means our time here has been has been used rightly. Somebody said, I wish I still can. Okay, you want to go back to the exam, all right? Well, this is a step in the right direction. So thank you guys for joining. This is quite interesting. We'll start our classes on foundation and combination tomorrow. So get set, right? So we would be meeting tomorrow again. And I wish you guys the best. Thank you very much. All right.